This conference will now be recorded.
Yeah. Is it visible and audible? Okay. Good evening, students. Yesterday, I have discussed about correlated subquery. And in correlated subquery, inner query is going to be executed for each row of the outer query. That is, inner and outer queries are depending on each other and executing simultaneously. That's the name called correlated subquery. And looking the correlated subquery and the just nested query, both are looking same. But the question is how to identify the given query is correlated or not. So only one identification mark whenever we have a reference of outer query in the inner query. Whenever we have a reference of outer query, if used in the inner query, then the two queries are said to be correlated. Okay, so if it is correlated, you have to evaluate inner query for each row of outer query. Suppose if it is nested query, inner query has to be executed independently, then result will be used by the outer query. That difference you find it. Okay, next I am going to discuss one more concept called exists class. Yeah, please listen to me carefully. This is also important. Exists class. Now, what is exists class? The exists class is used to compare with an empty set. Here I am writing the exists class is used to compare with a set. The exists class is used to compare with a set. If exists class, if the set contains some result, it is going to return true. The exists class will check what is the result. Okay, it compares with the set. If the exists class contains some set of a result, then it is going to return true. If the result is empty set, then it is going to return false. Okay, so means exists class is used to compare. Here more specifically I'm writing exists class is used to compare whether the inner query contains some output, whether the inner query contains some output. If the inner query contains some output means result, then it is going to return true. If the inner query returns no output, that is called empty, then it is going to return false. Okay, so this is exists class. Now, and we can use this exists class with respect to correlated subquery also. Now here I'm going to show you one simple question that is going to use exists class and using a correlated subquery. Here, just I would like to take a copy of some table data. This table data I would like to copy because yesterday also we have discussed this queries based on this table data. Now, yeah, here you look at, I do have this table data, employee and managers. And suppose I do have a query, find name of the department. Yesterday we have discussed a query. Find name of the employee managing research department. Here, let me write the query also, question also. Find, the question is, find name of the employee managing department research. Okay, find name of the employee managing the department research. Managing the department research. Okay, find name of the employee managing the department research. This is a query. Yesterday I have shown you the same question in the form of a correlated subquery. Now I wanted to write the same query as a correlated usage of exists. Actually, generally exists class will be used in the correlated subqueries. Now, how can I read the query with respect to the exists class? So here, find name of the employee managing the department research. So means for each employee, we have to see, is that employee managing any department? According to the exist class, I'm reading the query again. For the employee 9, I will see whether that employee 9 first record is managing any department. Here it is not the management of employee 9. This is a management of employee 9. Okay. But what department that employee 9 is managing? Here science. But what department we wanted? Research. So means for each record in the employee table, we should check whether that employee is managing any department. How can I compare this? Employee number equal to manages number. If manages, that department should be research, but here it is science, means it is incorrect. Is this the department managed by employee 9? No. So means when I'm checking the comparison of 9 Priya with all tuples of managers, Priya is managing some department. This is matching, but name of the department is science, not the research. So no tuple is selected. Because no tuple is selected, for Priya, result is not existed for managing department research. Then the Priya is not in the output. Now this is to be carried for each and every record. Like similarly for Narendra also it is going to be verified. For Narendra too, we don't have any related record in the managers for managing some department. So Narendra not possible, Karthik not possible, for Teja is not possible because 4 is also not managing any department. Now it has to check one by one all the records. Similarly, the last record, the 6 is also managed. Right now, 6 is an employee, is managing some department. 6, so he's managing some department. What is the name of the department? Research. So means when I'm checking for Akhil is managing some department. Name of the department is research. Means for Akhil, the required combination is available in the managers. So means some record is selected. And for remaining records, it is not selected. Because one record is selected, means for Akhil, one record is selected. It means some output is there in the inner query. Because output is there, the tuple in the outer query is going to be selected. That is, Akhil is going to be selected. So in the way I have explained, I'm going to write the same thing. So what I wanted to select employee name. It is from which table? From the employee table, where for each employee we have to check the inner query. Means for each employee, a managers table is to be executed and verify that in the managers table is it has any output. So means we have to write where exists of, we have to select some output, because exists is used to test whether the inner query contains result or not. That's why it is a default practice that it requires to use star. It is from managers table, where how we have to check for that employee. We have a matching record. We have to write a condition where employee dot e number equal to managers dot e number. So it means that for that employee we have some record in the managers, and if that record, if that employee is having some managers record, that department name, d name should be research department. So it means if for that employee, if the manager's record is available and the name of the department is research, then we will get some output in the inner query. If we get output in the inner query, that corresponding employee name should be in the output. Now for which employee we can see the output for that employee name, Akhil, we can see such two combinations are to be true. For Akhil, 6 equal to 6 is true for this row, and department name is research is matching. The two conditions are matching when I'm comparing with the 6. So result is there. Because result is there, exists of result returns true, so that Akhil is in the output. For remaining all records, the two combinations, two conditions that I have written in the inner query is not true, so that no employees matching in the no employees matching in the inner query, so that it is not giving the output. Only Akhil is in the output. And what type of query it is? It is correlated sub query. Why? Because in the outer query we do have employee table. That employee tables employee number, employee tables employee number is in the inner query. Means outer query reference is used in the inner query. Then we can call the query is called correlated subquery. It is called correlated subquery. Fine. Is it clear? Have you understood what is exists class and how query is executing and how it is comparing? Hello. Is it clear? If it is clear, we'll quickly move to one question. Yeah. We'll quickly move to one question. First, you try. I will give you 2 minutes of time. Okay. So yeah, Sai already started recording. Okay, fine. Now, first you give a try for this InfinityK question. Later, we will discuss. Later, I will explain you each and every question. Yeah. Here, have a look this question. Yesterday, I told you to take a snapshot of this question and asked you to try. I hope you tried it. And anybody tried and got an answer for this question? If tried and got an answer, please reply to me. And before me explain, I suggest you please try it once. I'll give you 2 minutes of time. Please try it. Yeah, is it right? Any answers? Just let me check and explain you. Listen to me carefully, and moreover, you need to have a patience to understand this concept. Any answers? Okay, no answers. I think, are you trying? If you're trying, okay. Okay. But listen to me carefully. Here, what is given? Consider the tables book and library registers. Two tables are given, book and library registers. Fine. Here, this is a query. Look, here we do have a two queries and exists class. In the outer query using library L1, book B, and inner query using library L2. And here we have a condition L1 issue date equal to L2 issue date. Means L1 is a table in the outer query, means outer query reference using in the inner query. Because outer query reference is used in the inner query, we can call the two queries are said to be correlated. Here also you see L1 issue ID not equal to L2 issue ID. Okay, and L1 return date should be equals to L2 return date. Three conditions are there. Okay, so first you should understand what it is performed, what it is checking. First, it is performing the join of library register L1 and book B. Join of library register L1 and book B is matching with 101, is matching with 10001. Okay, sorry, book ID, right? That is the issue ID. See, 1001 is matching with 1001. 1001 means this green color is matching with these two reports. Okay, and three records. And next 1005 do have a matches of 1005. Yes, here 1005. 1006, here it has one match. Okay, and 1011 is having a match with this, and last 1020, this one will have a match with this, right? Okay, so totally how many correct combinations are there? Here we do have a 5 correct combinations, and for 1008 we don't have any combinations, so this is not going to be in the output. So means these these how many combinations? For 101 we have a 3 correct combinations. For 1005 we have 1 combinations. For 1006 1 combinations. 1011 1 combination. 1020 1 combinations. So totally 7 combinations are there. For each of the combination, what it will do is it is going to compare the library register L2. So means again this same library register L2 is going to be verified, right? And where it is going to check what? L1 issue date equal to L2 issue date. So means issue date should be same. Here I'm writing. Please try to understand. You should have a patience. Same issue date. L1 issue ID not equal to L2 issue ID. L1 issue ID not equal to L2 issue ID means it should be different issue. Means it is not issued to the same student. It should be issued to the different students. Okay. Issue to different student. So because it is a correlated sub query, that record is going to be compared with itself only. That's why this L1 issue ID not equal to L2 issue ID says it is not going to compare itself. So means issue to different student we can call issue with different student. And the third condition, L1 return date equal to L2 return date means the return date should be same. Okay, L2 return date should be same. Return date should be same return date. Okay, now here we do have three conditions to be verified for each combination of the outer query, because outer query is a join of book and library registrar table. The join of book and library registrar tables, here it gives 5 combinations. Here look at, like, this 1001 is having a match with these 3. For each of the combinations, again this library registrar entire table is going to be compared. Why? Because the library registrar L2 is going to be compared for each combination of this join. Now look at, similarly it is for all combinations, means for 1005 we have 1 combinations. For 1005 this is 1 combination, 1006 1 combination, 1011 1 combination, 1020 1 combination. For each of the combination, this entire L2 is going to be verified. Now, with 3 conditions. First one, issue date should be same. It should be issued with different student. Second condition. And the third condition, return date should be same. Return date should be same. Return date should be same means it is issued on the same date. Okay, it is issued on the same date when L1 student returned it. Okay, so L1 return date equal to L2 return date. Look at that 3 conditions. Say for the first combination, that 1001, 1001, it is matching with 1001. Okay, I will be coming from bottom to top. Okay, this one 1001, where it is comparing with all records of L2. L2 is same records. What are the conditions? Same issue date. Same issue date. Here issue date is 12th Jan. And issue ID should be different, means issue should not be compared with itself, because issue ID not equal to issue ID means it is to be issued to the different student. Now look at this 1001, this combination I am checking with what conditions. Issue date should be same but issue ID should be different, so means this tuple should not be compared with itself. Okay, so this one I have to compare with the remaining. Now L1 issue date equal to L2 issue date, 12th Jan 2019. Is it there for anyone? Yes, 12th Jan 2019. So here this condition, because issue ID for this is 1004, 1007. That's why I'm going to compare with other records. Now issue ID is different and it should have the same issue date. Issue date is same. If issue date is same, then it requires to have the third condition. What is the third condition? Return date also should be same. Now what is the return date? 20 Jan 2019. Here also 20 Jan 2019. So means these 2 combinations are going to be selected. Means when 1001 compared with 1020, this combination, this 1020 is this one. Okay, this combination. When 1001 is compared with, when 1001 is compared with 1020, it is going to get some output, so that this 1001 combination is going to be in the output. What is the output? Book name should be in the output. Where is the book name? Book name is a brief history of time. A brief history of time. So what is the first output? A brief history of time in the output. This is book name. That is a book name. And next, this combination is compared with this combination. It is true. Oppositely also, when this combination 1020 is compared with 1001, issue IDs are different and issue IDs are different and issue date is same and return date is same. So 1020 combination is also true. So I will be writing here itself. This combination is true. Why? Because for this combination, issue ID is different, issue date is same, and return date is same. So that 1020 book, that is Cosmos, a person voyage. Cosmos, a personal voyage is in the output. Okay. Next, here these 2 are in the final output. Okay, these 2 are in the final output. Next, I will be checking with this combination. Next, one more combination. This combination I wanted to check. Now, issue ID should be different, and issue here, ID issue ID should be different, second condition, and issue date should be same. So now this issue date 12th February 2018 is same for 12th February 2018. Here issue date is same. If issue date is same, return date also should be same. What is the return date? 20 May 2018, but here 20 February 2018, but return date is different. But what is required? Return date should be same. Return date should be same. That's why this tuple is not going to be true. This combination is not true. Because this combination is not true, this combination is also not true. Not true. Okay, these two are eliminated. Then next one, you check it out. Because it is becoming clumsy, I'll be cleaning whenever it is required. Next, third combination 1001 is going to be compared with remaining all. Now, what is the issue date? Issue date should be same, 25th December 2018. Do we have any 25th December 2018? No. So that this combination is also not true. Next, look, already 1020 is selected. Already 1020 is selected because 1020 issue date is 12th Jan 2019. That is same as issue date of this record, and return date is same. Return date is same. That two already have written it. Now look for 1006. 1006 combination. Now it is 5th May 2019. 5th May 2019. But do 5th May 2019 is a correct combination for anything? Issue date, same issue date is there? No. Now same issue date is not there, means this is also incorrect. Now finally last one. 15 Jan 2018. 15 Jan 2018. Is it there for any other box? Same issue date, because issue date should be same. That is a first condition. Issue date should be same. 15 Jan 2018 is not same for any other issues. So that this is also not going to be selected. So what is selected? A brief history of time and Cosmos, a personal voyage. Both will be in the output. Now what will be the question? What will be the output when the above query gets executed? Because in the outer query we have exists class. For the two combinations, means for this combination and this combination, we are getting some output. So that two combinations books are in the final output. Now what is the final output? A brief history of time, Cosmos, a personal voyage. A brief history of time and Cosmos, a personal voyage is there in the option B. So B is the correct answer. And Gulliver Travels is not possible. And here Gulliver's Travels not there. Gulliver's Travels is not there. Only two books are there. That is A Brief History of Time and Cosmos, a personal voyage is in the final output. Is it clear? I have explained with utmost care and explained in a proper way. I hope every one of you understood the same. Is it clear? Hello. Clear. Right. Venkat Avinash. Nice. Now, may I give you one question to you, so that you can practice. Otherwise, may I go to the next topic. Yeah. I think this is a bit complex to you. Will you try this one? Will you try? Yesterday I told you now it is 3 queries: query 1, query 2, query 3. For each tuple of query 1, we have to execute query 2, and for each query 2, we have to execute query 3. So after executing query 3, it is returning some output, and after executing query 2, it is returning some output. See here, look at what is there. Customer, it requires to select customer name in the final output from customer C. For each customer C, it requires to check what? Here it requires to check for the condition gender equal to female for each customer. Here female, female, female. Only these three combinations to be verified. For each female customer, it requires to check what condition and exists of. In the inner query, here we have a output. selected. Select O1 dot customer ID. This O1 is called orders. O1 dot customer ID from orders O1 where quantity greater than 1. For each quantity greater than 1, quantity greater than 1, true, 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 true. Only this one. And this is greater than 1 condition is false for these records. So that should not be selected. Again for each of this. Again for each of that, quantity greater than 1. O1 customer ID equal to C customer ID. Customer ID should be matches. Okay, O1 customer ID is C1 customer ID because C is the customer instance which is there in the outer relation. So that for each female customer, these 6 records has to be verified. For what condition? O1 customer ID equal to O2 customer ID and quantity greater than 1. Quantity greater than 1 is for these 6. So for each customer, this records has to be verified. After verifying, it requires to group according to the O1 customer ID. Having sum of the amount. Having sum of the amount should be greater than in the inner query. What you look in the inner query, select average amount from orders O2. Again, this is the same O2 orders where O1 customer ID equal to O2 customer ID. Customer ID should be matches. Now, what is O1? O1 is the O1 is there in the its outer query because from here it is one more query, right? So totally we do have 3 queries. This is query 1, and from here to this it is query 2. From here to this it is a query 3, and 2 is depending on 1 and 3 is depending on 2. For each tuple of 1 we have to execute 2. Again for each execution of 2 we have to check with 3. Okay, this is how it is to be verified. And again here in the outermost we have exists class, and it's here in this its outer we have a greater than condition. Now we will check it out what output is to be possible. With utmost care I am trying to explain. Please listen to me carefully. You need to have a patience. Look at what should be in the final output. Final output should have C dot customer name should be in the output. C dot customer name should be in the output. Now from customer C, okay, this is a C where gender equal to female. Female records are 1, 2, 3. Okay. So means I have anyhow it has to be verified with every combination, but because the first condition is female, male records anyhow not going to be selected in the final output. So there are 3 records. For each of these 3 female customers, we have to check is the result existed in the inner query. Inner query started from here. Select O1 customer ID. This is to be selected from orders O1. This is a orders table we call O1 where quantity should be greater than 1. Here quantity greater than 1 is only for these 6 records. And O1 customer ID equal to C customer ID. O1 customer ID equal to C customer ID. Here this is a customer ID. O1 customer ID equal to C customer ID means here we check. For C101, do you have any combinations to be verified? C101 is matching with here this one. Any other combinations? No, only one combination, C101. Here, this is matching with this. Remaining is not matching because even this is matching, but its quantity is greater than 1 condition is false. Now, there's only one combination is correct. If one combination is correct, that one combination has to be grouped according to O1 customer ID. So means this is group is having only one combination, only one is selected. Having sum of amount. Where is the amount here? 2,333.45. This 2,333.45 should be greater than. It should be greater than what? In the inner query. This tuple has to be verified for the every tuple of inner query. In the inner query, we have orders O2, means same table once again, where O1 customer ID equal to O2 customer ID. O1 customer ID equal to O2 customer ID means here this O1 customer ID C101 is to be compared with all O2 customer ID, means again the same table. So C101 is there for this tuple and also this tuple, because this tuple is there in the O2 but not in the O1. Okay, right. Now, so what is finding average amount from orders O2 where O1 customer ID equal to O2 customer ID? Means for O1, C101 is there in the O2, C101 there in the O2. For these two, what is the average amount? What is the average amount means here 233.45 1040. So 233.45 plus 1040 by 2, this is going to be some lesser value than 233.45. So because it is definitely lesser value, this combination is selected, right? So this is going to be selected with a condition greater than condition, because here we have a greater than condition, greater than 233.45 plus 1040 by 2, it is definitely greater, because when you take average, it is definitely greater. Because greater, this combination is selected. Because this combination is selected, exist class is going to return for the outer query. So this customer is in the output. So what is the customer name? Ann is in the output. So Ann, ANN is in the output. Now anyhow, Ann is in the output. So Ann is not there in the option D. Okay, option C. So Ann, I'm removing it. Similarly, we have to check for the other combinations. Look at how I'm comparing. Please listen to me carefully. Now, Mary is a customer, female customer in the outer table. And for each female customer, what is to be verified? It has to be verified that orders O1, this table is to be verified. With what condition? O1 customer ID equal to O2 customer ID. Now, C102 is going to be compared with C102 here. And any other here, the C102. These two are correct matches. And maybe even any other non-mapping records are there? Not there. Okay, these two are the correct combinations. And these two are grouped by O1 customer ID. Means again, these two are forming one group. And what is the sum of the amount? What is the sum of the amount? Sum of the amount is 233.45 and 2999. So 233.45 plus 2999. So it is giving you 3232 here, sum 3232.4. Here also what is sum? 3232.4. Again, for each combination, what it is going to check the condition greater than, here this greater than condition. It is going to select average amount from orders O2 where O1 customer ID equal O2 customer ID. So what is the average amount for C102? We have only these two combinations, only these two. When you take the average, amount, average will be 233 plus 2999 here, 233 plus 2999 by 2. Definitely it will be greater than, definitely it is lesser value when compared with 3232.4. So that it is true for these two records. Greater than condition is true for these two records. For these two records, condition is true. Condition is true means Mary also is in the output. So Mary is in the output. Okay. Now, finally, third record, whether you will get Susan or not. Now look at Susan for this. What is the customer ID? C106. It has to check for each order. C106 is matching with C106 here. And it is matching with this C106, but quantity greater than one condition is failed. Only one matching is there. So this is only one correct combination. In the O1 table. And what is the condition? Group by O1 customer ID. That group is having only one record having sum of the amount. What is the sum of the amount? 1621.27. It should be greater than. Select average amount from orders O2, means for the entire table, where O1 customer ID equal to O2 customer ID. C106 is there with this tuple and C106, here it is also matching. For these two, what is the average? You can say 1621.27 plus, now for this tuple also 1621.7 by 2. So 1621.27 plus 1621.27 will give you 1621.27 plus 1621.21 21.7 by 2 will give you 1621.27 only. So means 1621.27 greater than 1621.27 condition is false. Because this condition is going to become false, will you expect Susan in the output? Susan, you don't get in the output. So what is the final output? Only Anne and Mary in the final output. Anne and Mary is there in the option A, but option B given only Anne. Anne is not there. Anne is not there. And here Susan is not possible. Susan is not possible. So that this is incorrect. Here it is given Anne, Mary, Susan. Susan is not possible. So that option D is incorrect. What is the correct answer for the question? Option A. Only the thing is, you require to have patience to solve this query. So otherwise you couldn't solve it. So how I have discussed for each customer, I have checked with O1 tables. In the O1 table, the conditions have verified. After verifying the conditions, that sum of that amount should be greater than all the records of O2 where customer IDs are matched. Then I'll be finding the final output. So means for each record of Q1, this is I'm calling Q1, it requires check Q2. Again, for each combination of Q2, it requires check Q3. So Q3 is giving some output. Based on that, this greater than condition is verified. And if greater than condition is satisfied, Q2 is giving some output. If Q2 is giving some output, XS is going to return true. If it is returned true, that customer name is there in the Q1 output. Final output is Anne and Mary in the final output. I hope you understood. I have discussed with utmost care. Hope you understood. And these are the two questions are there based on the correlated sub query and XS class in one of the Infosys InfyTQ paper. Okay. But and moreover, Infosys InfyTQ is common to CS and non-CS students also. Anyhow, this is a question appeared for CS student, means same question may possible for you people also. And you also have to solve the questions. And please practice as many questions as possible so that you will get a confidence on it. But don't give up. At least give it a try. At least give it a try. If you come close to it, you can able to select the correct option. Okay. But again, I'm telling you, please don't give up. At least you give it a try. At least you give it a try so that you can able to answer the question. Is it clear? Any doubts? Any doubts? Hello. Is it clear to everyone? I can understand it is very, very difficult for you, but required to understand. Is it clear? Abhinash, Sai Charan, Surendra, Vamshi, Karthik. Okay. Done. Clear. Okay. Naga Karthik, clear. Fine. Now I'm going to discuss one concept. Vamshi, very good, Nana. Right. I'm going to discuss one more concept called with class, and which is definitely useful. And before that, just let me show you execution of this correlated subquery. I have written now. Sorry. Yeah. Here I have written. I told you how query is going to be executed using exist class. Just we will execute this query for one time so that we'll get a confidence on that this question is sorry, here it is giving the proper output. Then I will discuss one more concept called with class. Fine. Here, listen to me. I would like to show you the execution. Yes, only the thing is you can type the query and see the output. Anybody tried of executing this? Executing the SQL statements. Anybody trying? Now, what is the question? You look at what is the question? Find name of the employee. Okay, Vamshi, very good, Nana. Find name of the employee managing the department research. So how this query is executing for each row of the employee, inner query manages its testing for the two conditions. One is employee number equal to employee number, and another condition is research. And we have used exists class. So for that employee in the outer query, if inner query is returned something, then that employee record in the outer output. So which employee is possible in the output? Akhil is possible in the output. So this query, I will just type it and I will show you that it is giving the output Akhil. Okay, because Akhil is managing the department research. Look at. So what you have to write, select. We have to select employee name, ename. It is from employee where exists of. What inner query is to be verified? Inner query should check with some output, so that we have to use select star from. It is from which table? Manages table. It has to be verified with two conditions. What are the two conditions? Where one condition is that employee should manage some department. If manage some department, you can see that employee number in the managers table. Employee dot e number is equals to managers dot e number. And it is going to satisfy one more condition. It requires to satisfy one more condition, that is DEPT name. Department should be which department I said? Science or research? It should be of research department, means D name should be research. So the second condition is DEPT equal to research. DEPT equal to research. And close this query. And because outer query reference is used in the inside inner query, then we can call this is a correlated sub query. Now select this query and click on run. You are going to get the output. Okay, here it is giving error that DEPT invalid identifier. Means, do we have what is the name of the department in the managers? And the name of the department in the managers is not DEPT, it is D name, right? D name. So that it is not going to give an any error. So you should be able to understand what kind of errors are given. Like here it is given in the bottom of the screen, you can see DEPT invalid error. It means DEPT I used and that is not an attribute of managers table. Then just if in such cases, you can just check what is the attribute name in the managers table. Accordingly, you can go for the correction. Okay, and click run. Now I'm getting the output ename Akhil. I'm getting the output ename Akhil. So it is returning one row in the outputs. Okay, this is how correlated subqueries are going to be executed. Now I'm going to discuss one of the beautiful concept called with class. And using with class, you can write complex queries in a simpler way. Let me explain the concept of with class quickly. And definitely this will be helpful for writing many complex queries in a simpler way. So, okay. With class. Here, what with class? I'm writing for you for the sake of notes. With class is used to create a temporary relation. Create a temporary relation and whose definition means whose result, or else instead of giving the complex sentences, I'll give a simple sentence. Whose result is available to the query. Whose result is available to the query. Whose result is available to the query in which it is defined. In which it is defined. It is just like a subquery. So means this with class, if I use, it is going to create some temper relation, and that output of the temper relation means result is available to the query in which it is defined. It means that subquery, like with this like a subquery, the subquery output is available in the query itself. Out of the query, that result is not available. So means if I do have a complex questions, we can make that complex questions into in a simple query. We can write in a simple query. Let me explain one simple query. Sorry, let me explain one concept, one question with respect to with class. Here, have a look. I do have a table called professor, assume, having some attributes. 1 minute. Or else instead of professor, I would like to take the same employee table. Just I would like to take this employee table. Instead of professor, I will take employee table. Yeah. Sorry, what happened? Yeah. This is an employee table. Okay. Now I wanted to write one query. I wanted to write one query where the question is find name of the department. Find name of the department whose total salary is greater than the average total salary is greater than average total salary of all departments. So find name of the department whose total salary is greater than the average total salary among all the departments. Okay, now just think about the question in the context of the table of data given, and you tell me which department names are going to be in the final output. Here, you forget about how to write a query. I will explain you. But first, you understand the question. According to your understanding, you tell me which department name is going to be in the output. Forget about the query. I'm not asking you to write a query. I'm asking you to what output is possible for this question. If you're able to know what output should be there in the query, that is more than sufficient. That means a lot for you. If you understand the question, what output is possible, then you can easily answer the question. Can you see? Have you understood the question? Have you understood the question and tell me what output should be there? Hello, have you understood the question or not? Okay, let me explain. First, I will explain you the question. What is the question? Find name of the departments. Here in this table, we do have three departments. First, understand the questions. We do have three departments: ECE, IT, and CSE. Three departments. So it is asking you to find name of the department whose total salary should be greater than average total salary of all departments. So it is required to find name of the department whose total salary means for each department what is the total salary. The total salary should be greater than average total salary of all departments. Now you tell me how to find total salary. I can find total salary by writing sum of salary. That's it. Okay. This sum of salary of a department, this is to be find for each department. Now, each department means name of the department whose total salary. So means we have to divide these employee records into groups according to their department table. The total salary of the department should be greater than the average total salary. Very good, Abhinash, CSC and ECA. The average total salary of all departments. How do you find average total salary of all departments? So means it is 90 plus 35 plus 50 plus 60 plus 60 by is it 5 or is it 3? So 90,000 plus 35 125, 125 plus 50 175, 175 plus 60 plus 60 120, 195 295. Okay, this is totally 295k. By how much it is 295k by, is it 3 or by 5? So means when I have to find average total salary of all departments, I said. So means if I say average total salary of all departments, what is the meaning? How many departments are there? Three departments. Three departments means CSC, IT, EC is there. So that it should be by 3. Because it should be by 3 means it is not average of salary simply. It is not average of salary simply. This is sum of salaries by number of departments. So sum of salaries is 90k plus 35k plus 50k plus 60 60 120k. That is 295k. Okay, that 295k means 90 plus 35 125 plus 50 175 plus 120, 295k by 3. 295k by 3 will give you how much? 3 nines are 3 eights are 98 something 98k something, it is giving 98k. Okay, 98k 98,000 something 98,333. Okay, very good. So Venkat Abhinash, excellent. 98,333 is given. Now what is the sum of salary for the EC department? 90. EC department 90. What is given? Total salary should be greater than average total salary of all departments. So total salary is 90,000. Is it greater than average total salary of all departments? 90,000 greater than 98,333? Wrong. So that EC department should not be in the output. For IT department, 50 plus 35. Total salary is 50 plus 35, 85,000 only. But is it greater than average total salary of all departments? No. IT also incorrect. Now, CSE department should see. What is the total salary of CSE department? 120k. That 120,000 is greater than 98,333. True. So that what tuple should be in the output? That name should be only CSE. Only CSE departments total salaries are greater than average total salary of all departments. Are you getting? Now I got an answer for the query is CSE. Next I will explain you how to write this query. First you tell me, have you understood the question and have you understood the output? Venkat Abhinash, I think you gave ECE and IT, CSC and ECE. Surendra, ECE is not possible in the output, correct? Have you got have you understood why CSC is okay? Right. CSC, ECSC is there in the output. EC is not in the output. Okay. Now, have you understood the question? Now, question understood. Now here, actually, this is called a complex queries. You can write complex queries, any complex queries in a simple queries. Now, using with class. Here you observe what is required. Here, this query requires three things. First, it requires to find total salary among each department, correct now? So what is the total salary of ECE? What is total salary of IT? What is total salary of CS? So this query requires to find total salary of all departments. Okay, this is one query. What second query requires? The second query requires to find average total salary of all departments. Average total salary. What I'm doing is I'm dividing this query into subparts. Average total salary of all departments. And then after finding average total salary of all departments, what you have to do in the first query, you found total salary of all departments. In the second query, you find average total salary of all departments. Then the third one, you find name of the department, name of department whose total salary is found in the query 1. That should be greater than the average total salary that you find in the query 2. So means you will be finding the final output in the third query. Means what I have done, because this queries, I feel it is complex, I divided this query into sub queries. Okay, listen to me. Because this query is a complex query, what I have done, I divided this complex queries into simple queries, subparts I have divided. Now, what I wanted to do is, the first query I will write separately. Look at how I am writing the first query. How to find total salary of all departments? I have to write in this way. Select. Okay, I will write with that. How I can find total salary of all departments? Select department name, and total salary means sum of salary. It is from which tables? From employee table. How can I find the total salary of each department? Requires to group the employee records according to the department. Okay, very good, Vamshi. Group by department. Okay, so that what it will do, EC is forming one group, IT is forming second group, CS is forming third group, and on each group it is going to find the final output, department comma sum of salary. Okay, here have a look. This department comma sum of salary. First one, for the first tuple, department is ECA and sum of salary is 90k. Okay, just I'm writing 90k. And for second one, IT department, what is the total salary? 85k. And for the third department, what is the sum of what is the third department? CSA, and sum of salary is 120k. Right, this is in the outputs. Now output of this query I will be stored as a temporary table. I will be used as a temporary tables. If I wanted to use this as a temporary table, we can create a temporary table using with class. What is with? With is used to create a temporary relation. It is used to create a temporary relation. So what we have to do is, just we have to add one sentence before this query. With here I will be creating a temporary table. That temporary table name is total of department D, department DEPT. Just I will be using some different name for the total table, DEPT, comma, and sum of salary I'll be calling as total salary. Okay, tot. Okay, just I will be using tot as this, put entire thing in the parenthesis. Put entire thing in the parenthesis. So means what actually happens is, it is going to, with class is going to create a temporary table. The temporary table name is total. Here I am writing total, and with two attributes, DEPT and tot, two attributes. And the result of the table means the output of the content of the table is the output of this query. Output of this query is the content of the table total. Okay, now next what you have to do is, you have to find the second one, average total salary of all departments. How can I find average total salary of all departments? Simple. I need to select I need to select average total, AVG, of this tot table, tot attribute, tot. From which table? From this temporary table, total. From this temporary table, total. Now what you have to do is you have to put this output of this AVG tot. Now what is the output of this AVG tot? AVG tot output is 90k plus 85k plus 120k by 3, correct? Now why? Because now I will be calculating average from total. Average from total table means here we have 3 records. What it will do, 90 plus 85 plus 120 by 3. So it is going to give you 98,333.33 something. Okay, this is the output. Now what I have done, this output I have calculated from the temporary table. That's why I'm not using any comma, semicolon, full stop. I'm not using, I'm writing this complete thing as a one query. So that this temporary table, this output should be used as again a temporary table. Because this output should be used as a temporary table, what you do is the temporary table name you give it, say average of the attribute name. I'll be using AVG1, some name I'm putting, okay, AVG1. And what is the table name? Average. The table name is average and the attribute name is AVG1. As this one put in the parenthesis. So what is the meaning? It is creating, because width is to be used only for one time. And here, and because width already used in the first one, so it is creating a temporary table called average, whose attribute is AVG1. And the result of this average table is the output of this query. Select average of total from total. When you have to write more than one query, more than one temporary queries, temporary relations, you have to use comma after the first one. Here this is the second one. Now what is it finally third one? What third one I wanted to do is I have to find department name. So what I will write is just I will be writing select DEPT. This one I will be selecting, okay, DEPT. It is from which table I have to select? Total table, TOTAL, comma. This is also have to be verified with average table, means this department total should be greater than average. So that I will be joining these two tables, total comma average table. What conditions I can write? Where this tot should be greater than this AVG1. Okay, now look at 90k. This is combinations right now. So 90k this one, 85k this one, 120k this one, right? Now 90k greater than 98,333, wrong. 85k greater than 98,333, wrong. 120k greater than 98,333, right? So means this is matching. Because this is matching, now what is output? CSC. So what is the final output? Now final output, it is going to find DEPT in the output. Which DEPT in the output? CSC in the output. So this is how we have to write a query, which is a complex query. You can divide that complex query, any complex query, any query. So far, whatever you have written, what you do is any query you divide into subqueries. After dividing subqueries, each query output you create it as a temporary table using with class. The output of this temporary table you can use as a input to other table, means as a output of the temporary table will be used as input to another query. Say here first I created temporary table total. This total I used in the second query to find the average total. Next in the third query, because I wanted to find the final output, so no more temporary tables. I didn't wrote with above this selected department. Now, so what I have wanted to use these two temporary tables, total and average, to find the final output. Okay. Now, this is how we can write a complex queries into a simple one. Complex queries into simple one. Now I will show you execution of this with class query. Listen to me carefully. So I hope you understood. Any doubt with this execution? No. Okay, finally, just I wanted to type and show you the final output. Now, what is required with you have to create what table? Just I wanted to use the same table names what I have written here. Table name is total. Table name should be total with total of two attributes. One attribute is DEPT, comma another attribute is what is the other attribute name I used? Tot. 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 This is a table I'm creating as. Now here I'll be writing one subquery. One subquery I'm writing. What is a subquery? I wanted to select department name and sum of salary. So department comma sum of salary. Department comma sum of salary. It is from which table? Employee table. How I can get it? This group by what department? Group by department. So this is going to give you some temporary table. This temporary table output I wanted to use to create one more temporary table. That one more temporary table I am calling average. And this average, it requires to find an attribute. It requires to find average total. So that attribute, I'm creating one temporary table called average. Sorry. Okay, average. And that attribute name I would like to use is avg1. Fine. As, and moreover, whenever you are writing multiple subqueries, you have to use just one comma here. Okay. Now, now I would like to write one temporary table again. What I wanted to find is select average of total. The thought I wanted to use it. The tot attribute which is created in the first temporary table. It is from which table? First temporary table, that is total. That is the output of the first temporary table. Now finally I will be writing the final query. Now because you are writing the final query, look at, so you should not put any commas here, and the final query should not be created as a temporary table, because that final query make use of these two temporary tables and going to display the final output. So what you wanted to display, select. I wanted to select name of the department. So here DEPT I wanted to display. It is from which tables? These two tables, two temporary tables that I have created. Total, and moreover I do remember that is I'm calling temporary tables. Once this query is executed, if you wanted to display the temporary table output, it is not possible. That's what I said. The result is available only to this query, not to other queries. From total, comma one more table is average. One more table is average. Right. Select DEPT from total, comma average. Fine. Now what is the condition we have to check? Where it requires to check a condition that tot should be greater than AVG1, correct? The total salary should be greater than average total salary, AVG1. Now put a semicolon. That's end the query. Fine. Now execute the query and see the outputs. See the outputs. Here I am getting the CSC in the output. CSC department salary, total salary is greater than average total salary among all the departments. This is how we have to write the queries using with class. So actually, especially with class is for making the complex queries into simple. If you have any complex queries, you can write that complex queries in a very simple way using the with class. But before you start writing the query, you first understand the question. That is what I am telling you always. You first understand the question. After you understand, then divide the question into subparts, and each subpart you create as temporary table, make use of a proper way to find the final output. And especially in the interviews, in the personal interviews, if the interviewer asked you to write some query like this one, if it is given, you have to write. I suggest you to write instead with using with class instead of trying in a nested query or correlated query or something else. You can write in a with class, so that definitely interviewer going to get impressed. Fine. That's about today's session, and thank you. And next class we do have on Wednesday, and one more class on Friday we have in the next week. So 1 minute, let me stop recording.